This video is on examining the shape and structure of quadratic functions. A quadratic function is a function in which the greatest exponent of the variable is 2. That is, it contains an x squared but no larger exponents. The graph of a quadratic function is a parabola. Its vertex is the highest or lowest point, depending on the direction of opening. If the graph opens upward, then the y-coordinate of the vertex is a minimum value of the function. If the graph opens downwards, in other words, if it looks something like this, then the y-coordinate of the vertex is the maximum value of the function. The axis of symmetry is a vertical line that passes through the vertex about which the graph is symmetric. Its equation is x equals the x-coordinate of the vertex. Since it goes through the vertex, its equation is going to be based on the coordinates of the vertex. The y-intercept is where the graph crosses the y-axis, that is, when x is equal to 0. And the x-intercepts are where the graph crosses the x-axis, when y is equal to 0. The domain of a quadratic function is all real numbers. In other words, x can be anything. The range of a quadratic function is based on the y-coordinate of the vertex and the direction of opening. So for example, in the graph above, the range is y is greater than or equal to -4. Because at this point here in the vertex, y is equal to -4, and all of the other y values on the graph of the parabola of the quadratic function are getting greater than that. The most common ways to write the equation of a quadratic function are the following. General form, which is f of x equals ax squared plus bx plus c. Standard or vertex form, which is f of x equals a times the quantity x minus h squared plus k. Or factored form, which is f of x equals a times the quantity x minus p times the quantity x minus q. When the quadratic function is written in general form, the x-coordinate of the vertex is x equals -b over 2a. The y-coordinate of the vertex is y equals f of -b over 2a. In other words, whatever you found the x-coordinate of the vertex to be, plug that back into the function and it'll give you the y value of the vertex. And the y-intercept of the graph is the value of c. When the quadratic function is written in standard or vertex form, the vertex is the point hk, where h is whatever number is being subtracted from x, and k is whatever number is being added on at the end. And when it's written in factored form, p and q, the values that are being subtracted from x, are the x-intercepts, or the zeros, of the function. For all forms of a quadratic function, a describes the basic shape of the parabola. If a is greater than 0, then the graph opens upward. If a is less than 0, the graph opens downward. If the absolute value of a is between 0 and 1, in other words, if a is a fraction between 0 and 1, then the graph is vertically compressed, it's wider. If the absolute value of a is greater than 1, so it could be 2 or -2 or 3 or -3, then the graph is vertically stretched, it's narrower. To graph a quadratic function, we want to identify the vertex and make a table of values in which we choose at least two x values that are smaller than the x-coordinate of the vertex and two x values that are larger. So let's do an example here together. We need to graph f of x equals -x squared plus 6x minus 5. We need to identify the y-intercept, the equation of the axis of symmetry, the maximum or minimum value, and the domain and range. So the first thing I think I'd like to do is to find the vertex. Remember that the x-coordinate of the vertex is the opposite of b over 2 times a. So that's going to give me -6 over -2 or 3. Plugging that back in is going to give me the y-coordinate. So 3 squared is 9 times -1 is -9 plus 18 minus 5 is going to give me a y-coordinate of 4. So my vertex is the point 3, 4. Also, remember that the x-coordinate of the vertex is going to give me my axis of symmetry. So my axis of symmetry is the vertical line x equals 3. So I can go ahead and graph a few of these things here. So the point 3, 4 is going to be my vertex. I also know that my y-intercept is going to be the value of c, which is -5. So I know I'm going to have a y-intercept of -5. Okay, and I know that since a is -1, that means that my graph is going to go like this, and my vertex is going to be a maximum value. So I'm going to have a maximum value at whatever the y-coordinate of the vertex is. Y is equal to 4. That's my maximum value. I know that my domain is going to be all real numbers. And my range, since this is going to open downward, is going to be y is less than or equal to the y-coordinate of the vertex, which is 4. Now I think all that remains is to make a table of values, and that's going to include the vertex. So I'm going to put my vertex in the middle, 3, 4, and I'm going to choose 2 x values smaller and 2 x values larger, and go ahead and plug those in. So when I plug 2 in, I end up with y is equal to 3, and when I plug 1 in, I get y is equal to 0. And since I know it's symmetric, that's going to be 3, and that's going to be 0 as well. So I have the point 1, 0. I have the point 2, 3, and the point 4, 3, and the point 5, 0. And actually, I had my y-intercept over here. I could actually, since it's going to be symmetric about this line here, that's my axis of symmetry, x equals 3. I know that then there's going to be a point over here as well. And then we just connect those. And I think I got all the parts. Y-intercept, axis of symmetry, maximum or minimum domain and range, table of values, and a graph. Good. So in this video, we took a look at some of the characteristics regarding shape and structure of quadratic functions, how to find vertex, axis of symmetry, y-intercept, maximum, minimum, domain, and range, and then how to make a table of values and graph.